ordinary differential equation, and we are going to look how to solve a given equation using method of exactness. Exactness. So, under method of exactness, you can be given a question in this form, like 2 x squared plus y squared, this one being dx, plus 4xy, this one being dy, which should give us 0. This equation should give us 0. So once you are given like this, what you normally do is to know that this part under the x is the part we call m, and the part under the dy is the n part. So what you normally do is you differentiate the part m with respect to y. You differentiate with respect to y. Then you equate to the part with n with respect to x. This one they should be equal. If for us to see that the equation was exact. And for example, we are given this, let's differentiate m, and our m is 2x squared plus 2y squared. Then the other side, we have 4xy, then this one is our n. So let's differentiate our m with respect to y. It will be, if you differentiate this, so the m, the y should give us what? If you differentiate this one will act as constant, and once you differentiate a constant, you always get 0. So the other part will give us 4y. Then let's differentiate this one, and it will be dn dx, and it should give us this one. Once you differentiate with respect to x, you will also get 4y. Hence, you are able to see that the question was exact. So once you get this, you have to know that your du dx should give us m, and we have the part. This part we said it is the m part. So just say it is the du over dx of m, and our m is 2x squared plus 2y squared. So when you have this, you can multiply through by dx. So multiply through by dx, multiply by dx, both sides. So these and these cancels, and you are getting your equation as du is equivalent to 2x squared plus 2y squared dx. Then, for us to get u, you just integrate this and you integrate on both sides. So get your u in terms of x and y should give us what? Once you integrate 2x cubed, you are going to get it is 2 over 3 x cubed plus this one. Once you integrate, you are getting it is 2x. Not that there is no x. X will appear now to be 2x y squared plus a constant. Once you integrate, there must be a constant. But since we are integrating with respect to x, then our constant should be in terms of y. So this is what we have as u. So you have 2 over 3 x cubed plus 2xy squared plus function of y. So once again, when we have this, we should differentiate this. Now that its derivative should be equal to our n. So let's differentiate with respect to y. What are we getting? So you just define your du dy, your du dy, as we said earlier, it should give us n du dy. Du dy should give us n, as we said, du dx should give us m. So let's differentiate this. This is our u. So it is giving us what? This is a constant. Since there is no y, it will just become 0. And you look at the other one. So once you differentiate that one, you are getting to the 4xy. Now that we are differentiating with respect to y, plus f, then f prime of y. Once you differentiate y with respect to y, you are getting f prime of y. Then this one, you should equate with the one that we said that this part, once you differentiate, you are getting n. And our n was 4xy. So you just say 4xy plus f prime of y should give us our 4xy. So are you able to see that once this you take to the other side, it just cancels, it becomes 0. So our f prime of y should give us a 0. So even if you just integrate on both sides, then you are getting your y is also 0. So your u will remain to be 2 over 3 x cubed, x cubed plus 2xy squared. Now that this one is 0, then you just leave it at that point. So this is the final answer. This is your u in terms of x and y. Yeah.